Hi, welcome to my video on an extra problem. We're going to solve a system of equations. One equation is ellipse, another one is a parabola, and we're going to solve them by graphing and algebraically. Here we go. Graph the system, and the system has an equation of an ellipse which has a center of 1, 1, and has a horizontal stretch of 3 and a vertical stretch of 2, and we have an equation of a parabola. So the ellipse is here. Write the first equation down. This is number 1, and this is number 2, and that's over 9, that's over 4, 1. So the center is 1, 1, which is the opposite of -1 for x, the opposite of -1 for the y, and it has a squared is 9, a is plus minus 3, so the horizontal stretch is 3, and b squared equals 4, b equals plus minus 2, so the vertical stretch is 2. So let's graph the ellipse, which has a center of 1, 1, which is right here. X is 1, y is 1. The horizontal stretch is 3, so it's 3 to the right, 1, 2, 3 there. 3 to the left, 1, 2, 3 right there. And the vertical stretch is 2 from the center, so you go 2 up and you go 2 down. So this is the ellipse, and I'll just draw a rough sketch. And the ellipse is oval in shape. Notice that this is 3 to the right, 3 to the left, so that's 6 long. That's 2 up and 2 down, so that's 4 long, so it's an oval shape. Now, let's write the equation 2, which is the equation of the parabola, and y equals x squared minus 2x. A is 1, b is -2, a is 1, which is right here, b is -2. So we want to graph this parabola, so one of the ways is to find the x-coordinate of the vertex. So the x-coordinate of the vertex is -b over 2a, which is the negative of a -2. b is -2, all over 2 times 1. So that's 2 over 2, which is 1. So if the x-coordinate is 1, let's sub in this equation, let's put 1 in for x to find what the y is when x is 1. When x is 1, put a 1 in. 1 squared minus 2 times 1. And we do PEMDAS, we do the powers first, so 1 squared is 1. Then we'll multiply next, and we'll get a -2. So PEMDAS, P-E-M-D-A-S is the order of operations, and the inside of the brackets are done. The powers first, which is the 1 squared. Then we do the multiplication, then we do the subtraction. So that's the vertex, V for vertex. The vertex is x is 1 and y is -1. Okay, so the vertex is x is 1, y is -1, so there's the vertex right there. So what we'll do now is find the X intercepts. So the X intercepts, we find the X intercepts when you let y equals 0. So in this equation, y is 0, and I'll solve the equation for x. So we take the x out by GCF because we got a quadratic. So x equals 0, or x minus 2 equals 0. So x equals 2. So when x is 0, so x is 0 when y is 0, and also x is 2 when y is 0. So these are the two intercepts. So intercept is 0, 0, which is the origin here, and the intercept is 2, 0, which is here. So this parabola leaves the vertex, goes up through this intercept, and it goes up. And again, this is only an approximation, and it leaves, goes up through, and this. So notice we've graphed the system, but we have one solution, which is right here. So this ordered pair here is x is 1, y is -1, but we don't know what this one. So we call this one A, we'll call this one B, and we'll call this one C. But we don't know what those values are. We know this parabola intersects the ellipse at 3 points. We have one of them, and we have to get the other two. So if we graph it, we can't solve it. We just can't find B and C. So we have to do it algebraically. So let's solve this system of equations algebraically. Here we go. So if we solve the system algebraically, let's take the first equation, which is this one. So this is equation 1, and this is equation 2. So let's write down equation 1, x minus 1 squared over 9, add on y minus 1 squared over 4 equals 1. So this is the first equation of the ellipse. So the LCD is 4 and 9 is 36. So what I like to do is multiply each part of the equation by 36, and that way we eliminate the fractions. 9 to 36 goes 4, so we get a 4x minus 1 all squared. 4 into 36 goes 9, so we get 9 times y minus 1 squared. 1 times 36 is 36. Now we have to do PEMDAS, so we have to do the square first before we multiply. So we square binomial, x squared, product is -1x doubled is -2x, -1 squared is 1, plus 9, and we square this binomial, so y times y is y squared. The product is -1y doubled, -2y. -1 times -1 is +1, equals 36. Now we have these brackets or squares, exponents done. Now we'll multiply. 4x squared minus 8x plus 4 plus 9y squared minus 18y plus 9 equals 36. And so we write the ellipse in the general form. So we get a 4x squared minus 8x let's go with the general form, plus 9. Make that a y. Sorry about that. That's a plus 9 y squared minus 8x minus 18y plus 4 plus 9 minus 36 equals 0. So we have 4x squared plus 9y squared minus 8x minus 18y, and that's a 13 negative 36. That gives me a negative 23 equals 0. So that's the general form. So what we'll do now is take the equation for y and sub it in. Notice we have x and y values in the general form, but we like to have all x's. So let's sub x squared minus 2x in the place of y. So we have 4x squared plus 9. Y is x squared minus 2x squared minus 8x minus 18. And y is x squared minus 2x minus 23. So now we have to do PEMDAS again, because we have to square first. So we have a 4x squared plus 9. So we square this binomial. So x squared times x squared is x to the 4th. The product is negative 2x cubed doubled is negative 4x cubed. And a negative 2x times a negative 2x is a positive 4x squared. minus 8x minus 18. And I'm just finishing this off, writing it down. Notice I did my exponent. The brackets you can't simplify, but you can do your power. Now I'm going to get rid of the brackets by multiplying. Remember, I'm following PEMDAS. So we get 9x to the fourth minus 36x cubed plus 36x squared minus 8x minus 18x squared plus 36x minus 23. And so we put it in descending order. I have a 9x to the fourth. I have a minus 36x cubed. And do we have any more x? So they're gone. And I have to do the fourth. I have to do x to the fourth, x cubed. Now I do the squares. So I got 4x squared plus 36x squared minus 18x squared. No more extra. Now I'll put the x's in. Minus 8x plus 36x minus 23 equals 0. And simplify that. I get a 9x to the 4 minus 36x cubed. When I add up all the x squareds, I get a 40 minus 18 is a plus 22x squared. Add up all the x's, and I get a positive 28x minus 23. Negative 8 and 36 is a positive 28. Notice that I have here right now that this is degree 4, largest degree, so that means I have 4 roots and 4 roots. This is a quartic. So to solve this equation means you must have done the unit on polynomial functions, where we solved different degrees of cubic, quadratics, quartics, quintics, etc. So we have 4 roots. Now, in order to solve this, we have to look at what I call Descartes' rule and determine the number of positive and negative roots. So I'm going to look at Descartes' rule of signs. So that's the positive and negative roots, real roots, imaginary roots, etc. So we have positives, real roots, we have negative real roots, we have imaginary roots, and we have a total number. So when I look at right here, I notice that this is one change, this is another change, no change here. So we have 3 sign changes here. We can have a 3 or a 1. That's the positive ones. So we can have a 3 or a 1 for the positive real roots. Now, if I put a negative x in the place of this equation, so if I sub in a negative x, I get 9 negative x to the 4th minus 36 negative x cubed plus 22 negative x squared plus 28 negative x minus 23 equals 0. So that's positive, so it's a 9x to the 4th. That's a negative, so that gives me a positive 36x cubed. That's a positive, so it's 22x squared. That's a negative 28x minus 23 equals 0. And now, that's for the negative real roots, no sign change, no. There's a sign change right here, so I have one possible negative root. So if I have 3 positives and 1 negative, notice we said we have degree is 4, so we have 4 roots. So there's 4 roots. That means we have no imaginaries. So there's 3 reals, positive roots, 1 negative real root. There's no imaginaries. If we have 1 positive and we have 1 negative, we have 4 roots. That means if there's 2 positive or 2 real roots, 1 is positive, 1 is negative, there must be 2 imaginary roots. So I know I have 1 negative for sure. So the steps that I use, that when you look at my unit that I did, I'll look at what we call the GCF. And the GCF, I look at the GCF of x. So when I look at this equation right here, this is the equation we derived, that I have x, 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 x. So there's no x here, so there's no x is the GCF, so 0 is not a root. And the next one I look is if 1 is a root. How do I know if 1 is a root? The sum of the coefficients is 0. So if the sum of the coefficients is 0, 1 is a root. So if we look at this equation here, I have a 9, 22, and 28, and that adds up to 59. If I look at the negative ones, I have a negative 36 and a negative 23. That's a negative 59. So notice they add up to 0. So 1 is a root. So let's do synthetic division with the 1. So I have a 1, and I look at this equation. So I'll write down the 9, negative 36, 22, 28, and negative 23. So I'm going to, if I know 1 is a root because the sum of the coefficients is 0. So that means the remainder that I'm going to get right here is going to be 0. So I draw a line, bring down the 9, multiply. 1 times 9 is 9, add, and I get a negative 27. 1 times negative 27 is negative 27, add, and I get a negative 5. Multiply 1 by negative 5, I get a negative 5, add, and I'll get 23. Multiply, 1 times 23 is 23, add, and I'll get a 0. And I always put that, that's my remainder. So if my remainder is 0, 1 is a root. But when I look again, I notice that I have a 9 and a 23, which adds up to 32. And I have a negative 27 and a negative 5, which is a negative 32. Again, the sum of the coefficients is 0, so that means 1 is another root also. So I have a 9, negative 27, negative 5, and 23. Draw a line, bring down your 9. 1 times 9 is 9, add, and I'll get negative 18. Multiply 1 by negative 18, negative 18, add, negative 23. 1 times negative 23 is negative 23, add, I get a 0. And I have a remainder of 0, which means that 1 is a root. So notice, this equation was the 4th power. So when I work, this is x to the 4th. So when I work this one, it should go down 1. So that's x cubed. Because I did it again, this is x cubed. So this should be an x squared. So this equation right here is 9x squared minus 18x minus 23 equals 0. So what I'm going to do now is turn the page and rewrite that equation. Because we have a quadratic, we did a unit on quadratics, many videos on quadratics. We're going to solve this quadratic, and if I have trouble solving it, I always use my quadratic formula. So here we go. The equation that I have is 9x squared minus 18x minus 23 equals 0. So A is 9, B is negative 18, C is negative 23. So the quadratic equation x equals negative b plus or minus square root b squared minus 4ac all over 2a. And so when we plug that in, that's the negative of b. So b is negative 18 plus or minus. B is negative 18 minus a, which is 9, minus 4 times a, which is 9, times c, which is a negative 23, all over 2a, and a is 9. And that gives me 8, negative of a negative, double negative is positive. And when you use your calculator and work this out, this works out to be 1152. Plug that in your calculator, work it out, and it's all over 2 9s is 18. Now, if we want the exact values, I could do an approximation, but I just want to work on the exact value. So I have 1152. And 1152 is even, so I divide 2 into 1152, I get a 576. Divide 2 into 576, I get a 288. Divide 2 into 288, I get 144. So that's the square root of 2 times 2 times 2 times 144. So the square root of, that's 2 times 2, which is 4, so that's a 2. Square root of 144 is a 12, and this 2 is left. So that's 24 root 2. So that's 18 plus or minus 24 root 2 over 18. So that's 18 over 18 plus or minus 24 over 18 root 2. So that's 1 plus or minus 6 into 18 goes 3, 6 into 24 goes 4 root 2. So I have the x values are 1 plus 4 over 3 root 2, and or you have 1 minus 4 root 3 over 2. So we have x is 1, a double root. Now let's take when x equals 1, and remember when we did the graphing, it was hard to tell, but we found when x was 1. So I'm going to take x equals 1 and sub it into the parabola. Easier to sub it into the parabola. So x is 1. So we work out the power first. Then we'll multiply. So I did the power, PEMDAS, to do the power to get the 1, multiply. You got to multiply it to get negative 2. And so this is solution here. X is 1, negative 1. X is 1, y is negative 1. Now we look at when x is 1 plus 4 over 3 root 2. So let's write down the equation of the parabola and sub that value of x in. So x is 1 plus 4 over 3 root 2 squared. 1 plus 4 over 3 root 2. Oh, I forgot. Let's put the 2 in front of there. So x squared, there it is, negative 2 times this. So let's take our time. Now we're going to square this binomial here. So 1 times 1 is 1. And we're going to go 1. So we're going to multiply these two. 1 times 4 over 3 root 2 times 2. So we multiply that out. I will get a positive 8 over 3 root 2. Now I'm going to square 4 over 3 root 2. 4 over 3 root 2. I'm squaring it. So I get 16 over 9 root 2 times root 2 is 2, so that gives me a positive 32 over 9. And negative 2 times 1 is negative 2. Negative 2 times 4 over 3 root 2 is a negative 8 over 3 root 2. Keep simplifying. They cancel out. So the common denominator is 9, so 1 is 9 over 9. 32 over 9. Negative 2 is 18 over 9. And when you add all them up, you get 23 over 9. So that means we have the x-coordinate is 1 plus 4 over 3 root 2, and the y-coordinate is 23 over 9. Now, that's the exact values, but if you want to do an approximation, use your calculator, and this comes out to be a 2.9 approximately, and this one is 2.55 repeating, so it's roughly 2.6. That's just an approximation as a decimal, but these are the exact values. Okay, now we got one more x-coordinate to do. One more x-coordinate, and that one is x equals 1 minus 4 over 3 root 2. The other one was 1 plus 4 over 3 root 2. So we're going to sub that into the parabola, which is y equals x squared minus 2x. So y equals 1 minus 4 over 3 root 2 squared minus 2. 1 minus 4 over 3 root 2. And we square this out. So again, 1 times 1 is 1. And we got a 1 times negative 4 over 3 root 2. So we product of these two, and then we're going to multiply by 2. So that gives us a negative 8 over 3 root 2. And negative 4 over 3 root 2. Negative 4 over 3 root 2. So remember, I squared this one to get 1. I got the product of these two doubled is here. Now I'm squaring the negative 4 over 3 root 2. That gives us 16 over 9 times 2. So that gives us 32 over 9. Negative 2 times 1 is negative 2. Negative 2 times negative is a positive 8 root 3, 8 over 3 root 2. I got to be careful of. 2 times 4 is 8 over 3 root 2, positive. And they cancel out. So y equals, common denominator is 9, so 1 is 9 over 9, plus 32 over 9, minus 2 is 18 over 9, so y is 23 over 9. So the x value is 1 minus 4. 1 subtract 4 over 3 root 2 is the x, and the y is 23 over 9. And use your calculator. This is the exact coordinates, but if you put this in a calculator, you get a negative 0.9. And this is the same as the other one, 2.55. It's 2.6 approximately. Now, let's go back to the first page that we did on graphing. Remember, these are the, this is intersect. We did the graphing. I made up this question to utilize many topics in math. Excellent question. So, go back. We had the A was the point where the parabola intersected here at 1, negative 1. B was 1 plus 4 over 3 root 2 and 23 over 9, and that became approximately 2.9 and 2.6, and C came to be 1 minus 4 over 3 root 2, 23 over 9, and that's approximately a negative 0.9 and 2.6. So that's the 3 points that the parabola and intersects this ellipse. And again, notice that it makes sense that this is the parabola here. So as you move 1 unit from the axis of symmetry is x equals 1. As you move 1 unit to the right and left, you get the same y values. You move x, you get y is 0. And when you move the same distance over here, notice this is 2.9 roughly. X is 2.9, you get the height is 2.6, and when you move this distance over here, you get the same y value as 2.6. So the vertex of the parabola is right in the middle, and as you move equal distance on the right, equal distance on the left, you pick up these two coordinates. I just thought I made up this question to review extra concepts in math, and a super question to do to review your skills. And that brings us to the end. If you like my video, click the like button, click the subscribe button if you're not a subscriber. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Hope the video was of some help to you, because doing extra questions means that you practice the extra math. Bye-bye.